Hey, welcome to Flemdog Tutorials. Today we're looking at this sample test problem. So in the previous video, we just looked at this practice test problem of burning propane. And in that, we solved for the amount of CO2 that is burned when you have 1 gallon of propane that gets burned in our scenario. Now what we're going to do is try to figure out our next question. So here's our question. Based on the mileage provided for each of the vehicles, our Ford F-150 getting 14 miles per gallon and the Prius getting 40 miles per gallon. Again, this is based on propane, and it's a hypothetical one that I made up, so probably not true to reality at all. Use dimensional analysis to determine the mass of CO2 that is produced per 1 mile. So we're trying to figure out the mass of CO2 and in grams produced per 1 mile. And then we're going to describe a claim about the effect of the vehicle's CO2 emission on the level of greenhouse gases in the atmosphere. The more insightful, the better. Let's begin. So we are trying to figure out, let's start out with the Ford F-150. So the Ford F-150, we're trying to figure out the grams of CO2 right there. So my grams of CO2. And this is for 1 mile. I'll put 1 mile right there in my Ford F-150. So we're trying to figure out 1 mile in relation to some unknown grams. So you might almost write it like, you might see it like this. 1 mile is some amount of grams CO2. So if that helped you to know what your initial piece of data was, you could interpret this question like that. So 1 mile over 1. Our next step is going to be to cancel miles. So I need to put miles right here, and we need to think about something that allows us to cancel miles. So we're doing the Ford F-150, and the Ford F-150 has this piece of data that 14 miles will go 1 gallon. That's what 14 miles per gallon means. So I can take my 14, my 14 miles and gallons right there, and in front of the miles units is 14, and in front of the gallons units is 1. That just allowed me to cancel miles and miles. And as a general rule, we're always just going to take whatever unit we're given and drop it down. So now we're into gallons. And we need to get something in gallons that gets us closer to grams. And what we have that gets us closer to grams is this piece of data. It says 1 gallon is 1,923 grams. This is grams. 1 gallon is equal to 1,923 grams. We'll just cross off one of those G's. 1,923 grams. So that got me gallons top and bottom, so I can cancel that. We'll get a new color here. Gallons gone. At this stage, it's easy to think like, oh, I got to grams. This is why writing down your actual full unit is really, really helpful. So check this out. This is gallons. Gallons of what? It's gallons of propane, C3H8. And this is gallons of what? Gallons of propane, C3H8. And this is grams, but not grams of CO2. It's grams of C3H8. So this was our propane conversion. So we haven't actually got to grams of CO2. We've got to grams of C3H8. So what we want to do now is get all the way over to grams of CO2. So let's keep going. And for this now, we're going to need to look at our balanced equation right here. And this is from our previous video, so if you haven't checked that out, you can, but you can also just look. We know that we're in grams, and anytime we want to go from one part of an equation to another part of equation, the first thing we have to do is get from grams into moles. So we can do that, and we showed the math of how to do that last time, but let's show if we did that all in one stoichiometric equation. So 1923 grams, we need to cancel grams of C3H8, and we need to go to moles of C3H8. How many grams are there per mole? Well, that's called the molar mass. And the molar mass of C3H8, I won't solve that out now, but I'll just tell you, it is 44 grams per mole. And what that means is, better get another color, it's already gonna get too busy. 44 grams is equal to 1 mole of C3H8. So 44 grams of our propane is equal to 1 mole of our propane. Now grams propane and grams propane have canceled, and I'm left with moles propane. Once you're in moles of propane, we can now, let me scoot this up just a little, we can now go from moles to moles of something else in the equation. In this case, we're going to moles of CO2. So how do we get from moles of one thing to moles of another thing? We use the molar ratio. That is where the balanced equation comes in. So we have 3 moles of CO2 that are made for every 1 mole of C3H8. Let's write that down right up here. I need to cancel moles C3H8, so I'm going to write mole C3H8, and we can see right here that there is 1 mole of C3H8 with our balanced equation. That's what our numbers out front refer to. The coefficients are that molar ratio number. So there's 1 mole C3H8, and we want to get to this moles for CO2, and there are 3 of them. So this is moles CO2. Now, what did we just cancel? We just canceled moles C3H8 and moles C3H8. Now I'm in moles CO2. Moles CO2, our final step is to get that into mass of CO2. So to get that into mass of CO2, we're going to need to multiply by the molar mass. So even if we didn't particularly know that, it's good to have a conceptual understanding of what you're doing. But if I wrote down mole CO2 and I wanted to get to grams CO2, I now have moles and grams, and hopefully when you see moles and grams, that's your hint that you're looking at molar mass. And molar mass is always about some amount of grams per mole. So in this case, our molar mass of CO2 we found is 44. So you could calculate that out if you would like, but our molar mass is 44. And what 44 means, I better write this, scoot this down just a little for a minute, is there are 44 grams of CO2 for every 1 mole of CO2. So I'm going to put that right in here. My number in front of grams is 44. My number in front of moles is 1. So 44 grams CO2 per 1 mole of CO2. Now, if I plug all this into my calculator, here's how I would do that. I'm going to multiply everything on the top, 1923, times 1 times 1 times 3 times 44. Okay, I got a really big number. Now everything on the bottom gets divided. So divide by 1, divide by 14. So let's divide this by 14 equals. Now divide it by 1, divide it by 44. The reason I don't type in the dividing by ones is the number stays the same, so I just leave those off. And that is my final now. 412 is the magic number I was looking for. So this means 412 grams. And if I did more sig figs, 412.1 grams CO2 are produced. So the final thing, I'll let you do the other one down here on your own. But the final thing that I need to do now is describe a claim about the effect of CO2 emission on the level of greenhouse gases in the atmosphere. The more insightful, the better. Without even doing this problem, I could at least make the claim that as I burn propane, I am producing CO2 gas. And you might think about, how is this connected to your life? Well, if your car is using 10 gallons a week, and we multiplied this by 10, that would be 4,000 grams. Over 4,000 grams that you're gonna be, you personally are using, or 4.1 kilograms. And 4.1 kilograms is over 8 pounds of CO2. So even if you didn't know how to do all of that, you could make the claim that as you burn your propane in your car, as the propane is burned, CO2 is released. And here's where you could connect what you are doing personally and your family to mitigate that and make that maybe a little bit smaller, or maybe you're driving a Ford F-150 or something to get back and forth to school, and you are really contributing to that heavily. You might say that you are riding your bike so that you're only producing the CO2 that you breathe out. And ultimately, though, your claim will tie into the data that you get from right here when you calculate this for the Prius and see the difference in those two numbers, and how potentially, if you have to use a car, using a car with better gas mileage, how that changes the CO2 emission that's there. So I'll let you work on that last one yourself, but hopefully that helps, and good luck on your celebration of learning.
Wonder, oh wonder, Flemdog Science.